Number 2 is another question that deals with a box plot. The only difference here is that the box plots aren't drawn for us. We actually are going to have to do that. Number 1, they drew it for us. Here we have to figure out the box plot. Now the 5-number summary is already given to us, so we don't have to type anything into the calculator and get our 5-number summary. That's given. Again, the part here that they're looking for is really more the analysis part, the comparison part. So part A says, use a scale to draw box plots for the temperatures of Pittsburgh and San Francisco. So we have temperatures of 2 different cities, Pittsburgh and San Francisco, and what we want to be able to do is then compare the temperatures between the 2 cities. So the first thing is that we're always going to want to do here is that we're always going to want to have a scale in terms of our numbers. Let's see, how much room do we need here? And scroll down there. This might be good enough. So let's say that we're going to make a number line down here, and we always want to label what our number line represents, which in this case is going to be temperature. And then we always want to label our units. So we're not talking about hours or miles or minutes or pounds. We're talking about degrees, right? Degrees Fahrenheit, right? So that would be our units there. As far as how do we label this thing, we're going to count by ones, we're counting by tens. Well, I think if we notice here, we actually just need to, on our number line, we don't necessarily need to start at 0. Because if you look at the temperatures, there's no, the coldest temperature is Pittsburgh at 34. So I don't have to waste time and energy graphing something that's not even there. So what I'm going to do is I'm just going to start with 30, since 34 is the coldest temperature. And then I'm going to do a mark. I'm going to count by 5s, but just so I can read it, I'm actually not going to label every 5. I'm just going to label every 10. So 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And let's see, what's our hottest temperature here? Hottest temperature is 83, so we can mark it to, let's say, 85, and we'll just go ahead and go to 90. Okay. All right, so we'll do one at a time. We're using one number line for each one of our box plots. So let's say, for instance, let's just start with Pittsburgh here, right? So here's our numbers for Pittsburgh, and we'll do this. I'll do this in different colors, not that you have to, but just so we can keep track of it. So Pittsburgh, actually let me highlight in a different color here. Let's go green on this one, fill in green. So Pittsburgh, and what we'll want to do is, because we're doing 2 box plots, we want to label it so that we know, which one is which. All right, so what's the median temperature? The median temperature for Pittsburgh was 54. So there's 55, so I'm going to put something kind of right about there. And I'm starting with the box part of it, and then we'll do the whisker part of it. So there's the median. My lower quartile is at 41, so I'll make a mark there. My upper quartile is at 78, so I'll make a mark roughly there. So here's my box. And then my whiskers are my highest and my lowest. So the minimum, it says 34. So let's say our whisker goes down to about there. Maximum, so our highest is at 83. So let's say somewhere right about there. And there's our box and whisker plot for Pittsburgh. So now let's do San Francisco. And we're stacking them. We're putting them on the same, using the same scale. Do red for this guy. So let's start with the median, and then we can do the comparison part. So median is at 63, so a little bit warmer temperature, and that should make sense. San Francisco, Pittsburgh, it snows a lot over there, so a little bit warmer temperature here. Lower quartile is at 60, so the lower part of my box is at 60. Oh, so that's not very far away, right, if I'm at 63 to 60. Upper quartile at 65. That's not very far away either. So notice that already you see the difference in shape between the 2 boxes here. This box is much more stretched out. This box is much tighter. It's much more compact. What's our coldest for San Francisco? Looks like our coldest was at 56. So we'll say maybe something kind of like that. And then our maximum, looks like we'll say at 69 degrees. Right? All right, so let's compare the two. Right? So we drew the box plots. So there's our box plots. We got our cities labeled. We got our units. So everything looks good there. So part B says write a few sentences comparing the variability, right? So if we talk about the variability, well, hopefully probably what jumps out to you right away is that Pittsburgh, it's much more stretched out, right? So in the winter it can be really, really cold. Maybe in the summer it can be pretty hot. What you notice about San Francisco is the box is much more compact. It's not as stretched out. So what that suggests is the weather there is more consistent. And we know that living in California, for instance, that our temperatures, you know, except for some Santa Ana winds and every once in a while, but for the most part our temperatures don't get really that hot and our temperatures don't really get that cold. So we have more consistent weather in California, whereas people that live in other parts of the country, let's say on the East Coast, again, summer might be really hot, winter might be really cold, so there's much more variability in temperature. So when we're comparing variability, what they want us to talk about is they want us to talk about the range. So the highest temperature, just so we can get some numbers on here, so again, the highest temperature that we saw here is 83, and then the lowest temperature that we saw here was 34. So if we talk about the range there, right, so that's a range of almost 50 degrees. Whereas if we talk about San Francisco, the hottest temperature we saw here in San Francisco was 69. And then the coldest temperature we saw was 56. So that's only a range or a difference of 13 degrees, not a very big difference at all, right? So what we could say here is that Pittsburgh's temperature. So Pittsburgh's temperature has more variability because, or let's say due to a much greater range of temperature as compared to San Francisco. Also, we may want to add in here too, right? So I could say that just as I could say Pittsburgh has more variability, I can kind of flip that around and say that San Francisco has less variability, right? So there's more consistency, right? So we could also add to that and say that more consistency is seen in the temperatures of San Francisco. Okay, and part of this, I should say, you know, we want to make sure that we're writing something that's complete sentences and grammatically correct. For purposes of the video, we might be doing a little bit of shorthand here, but the finished product we want to make sure is cleaned up. And then part C says you've been asked to report on this weather for the Weather Channel. I should mention too variability before we kind of go into part C. Variability, what they're referring to there is only talk about what we're talking about there is we're only talking about the spread. So they're not asking, they're not asking about outliers or which one had the higher median temperature. They're asking, when they say variability, they just want you to talk about the spread. They want you to talk about the idea of there being more variability due to that greater range. Or we could flip it around and say more consistency, which is seen in the other one, which is seen in San Francisco. If I was going to write up a report, so this is almost kind of what Part C is asking us, is almost kind of do what we did on this first problem, which is just what's the shape, are there any outliers, what's the center, and what's the spread. So what we're looking for here is that maybe just kind of pick out two of the things. We don't see any, we weren't given any outliers. I don't know, let's talk about who has the higher median temperature, right? So if we're doing a report for the weather channel, we can say that San Francisco has a higher median temperature with less, let's talk about the spread, with less variability as compared to Pittsburgh. So we don't have to get into the median of this is, what was the median here? The median, San Francisco 63.54. I mean, we can cite those numbers, but we can also just say that it had a higher median. Less variability as compared to Pittsburgh. So we've, in just that one sentence, we mentioned the center, which is median. Right, so when we talk about the median, so higher median, so we just mentioned the center. Less variability, we're talking about the spread. And then if we wanted, I guess if there was anything else that we wanted to talk about on that one, again, no outliers. We could talk about the shape. What could we say about shape here? We could mention that this is, look at San Francisco, it's pretty balanced there. So we might say that, that this is symmetric, right? Talk about, which way is this one? The distance from the median to the left whisker, median to the highest. It's a little more stretched out this direction. So we could say that that this one is skewed right, meaning that when it's warmer, the temperatures are more spread out. Or we could say that this one is going to be symmetric. This particular question, I don't have to include all of that. They were actually just looking for kind of 2 items there. All right, so go ahead and pause video now and try number 2 on the right side.